beyond 25 years of excellence. SA Engineering College has taken the forefront of technical education through its distinctively different and carefully nurtured standards. The college is approved by the AICT New Delhi and affiliated to Anna University, accredited by NBA, and also has an A grade from the NAC and is an ISO 9001-2015 certified institution. The college believes in the preparation for the life ahead in all earnest and provides every opportunity to grow beyond academics. In view of the same, many in-house programs like placement trainings, value-added courses, workshops, symposiums, and guest lectures are also organized to make the students industry ready. We all have assembled here today to motivate and cherish the young minds present among us. At this juncture, I feel honored to welcome our resource person for today, Mr. M.D. Naseem, proprietor, Asia Meditech, Padi, Chennai. We welcome you, sir.
Thank you. Actually, I have a technical issue in my audio. Is my audio audible for everyone?
Yes, audible, Naseem sir, audible.
Okay. Actually, I have a technical issue with my laptop. I'll be presenting with my laptop, but my audio is connected to the mobile. First of all, I would like to thank the management, the department, and SA Engineering College for giving me this opportunity to present on the topic. Again, I would like to just confirm that whether I'm audible or not. Hello? Yes? Anyone able to confirm that whether I'm audible or not, please? Yes, okay. So thank you. Shall I present my document?
Yes, sir. Yes, sir.
Okay. I think my presentation should be visible in just a second.
Yes, sir. It's visible.
Okay. So should I wait or shall I start, sir?
Yes, sir. We may start now, sir.
Okay, thank you, sir. So I'm here to talk about mechanical engineering application in our day-to-day life, how mechanical engineering is applied. And today's topic is going to be a very light topic. The whole concept of today's topic is you need to make a decision by looking at different factors of engineering. So let me start with mechanical engineering. Mechanical engineering is the branch of engineering which mainly deals with design, analysis, and manufacturing, and maintenance also. Let me make it much more simpler. If you want to make a table, okay, you want to make a steady table. So the first criteria would be what size you need to make the table. So what should be the height of the table? What should be the length of the table? What should be the width of the table? Okay, that's fine. So once that's clear, I'm going to make a table. And then analysis part comes. Okay, now I'm making a table. So what material should I use in order to make a table? Okay, how can I reduce the cost? Mostly analysis deals with the strength of the product which we make and the cost of the product. Okay, before making the product, you need to decide. So what material should I use in order to make the product? And how can I make it cheaper? How could it be design friendly? How it could withstand much better load? And get along with our design criteria such as the length, width, and the height of the table. Then you start to manufacture. And manufacturing, there are a lot of process, and you need to choose a specific process and a process which is cheaper and easy to make. Okay, there is no point in making a product which would cost you so much. And the last thing follows is the maintenance. Okay, once you release the product and the product is running very good, and everything wears and tears over a time, so maintenance is quite important. Okay, this is broadly about engineering. I'm not going to talk heavily about engineering. My concept is about application of mechanical engineering in day-to-day life. Okay, so here we have something called as toppling. So what is toppling? Is something you just push a glass of water. Will that water be toppled or not? Simple. Okay, so in this diagram, I have different, consider this to be a tumbler, inverted tumbler. and I have certain points, right? These points are called as center of gravity. Okay, center of gravity is a point in an object where the whole mass tends to act. First image, we can see that the center of gravity is placed located here. If you want to find out the center of gravity, if it is a perfect rectangle in shape, if my tumbler is in rectangle in shape, what do? Is I draw two diagonals, and my drawing is not that great. The intersection point will give you the center of gravity. Okay, so the center of gravity changes due to the shape and the mass distribution of the item. So as of now, let's assume the center of gravity is at the point. Okay, let's assume the center of gravity is at the point red pointed, and the property of center of gravity is that it directly points towards the Earth's center. So this center of gravity is directly pointing towards the Earth's center. If I apply a force, some force at the top, so what do you expect? The glass tumbler would tilt at this point. Okay, this point is hinged at the bottom. You could expect the tumbler to be tilted. So, but if you release that force, the tumbler would not be toppled. It will come back to its original position. Okay, so I just want you to note what is so unique and peculiar about this example, so that you could understand much and appreciate the design. So this also stands. So what's happening? I've applied a force. This is tilted by some angle. Okay, this is tilted by some angle theta. So now what I'm doing in this third condition, I'm applying more force. What is happening? More angle, it has been tilted. Now if I leave the force, what happens? The tumbler does not tilt. It stands. Why? Because I want you to look at the base, how the base is, how the center of gravity is falling through the base. Okay, here you can see now the distance between the center of gravity line and the base has reduced. Here it is almost at the tip, but this line has not crossed the base. So again, this scenario, stage 4, I'm still applying a force and I'm tilting it to a much greater angle. So this theta is much more. Okay, this theta is much more. So now you could see what is happening is this will now topple down. Why? Because the center of gravity line has gone past the base. Okay, again I'll do it. You can just see it. This is the base. What has happened? The center of gravity always points towards the Earth's center. This has moved away from the base. So this will cause toppling. So this will cause toppling. So for an object to topple, you have some conditions to satisfy. What are the conditions? The base, for the object not to topple, be stable, there are some conditions. Wide base and low center of gravity. Okay, so low center of gravity. So you can understand what wide base is. If this leg was designed much bigger, example, if this was like this, what happens? The base, this is the base. Okay, this is the base length. The base is much bigger. So this kind of configuration or this kind of design would be more stable. Okay, the center of gravity will be at some point here. It will be pointing down. In order to topple this, you need to push it to a huge angle. Okay, so then only this object will topple. So the idea here is to understand when an object topples and when an object becomes more stable. In order to make an object stable, a design stable, you need to have a wide base and low center of gravity. Okay, sir, how do you reduce the center of gravity from this point to a lower point? People might have a doubt. Okay, so I told you to calculate, to find out the center of gravity of a uniform object, you just draw two diagonals. Consider this to be a cylindrical or a cuboidal object. So this is a point of center of gravity, and this will always point towards the Earth center. Okay. In order to bring this point down, now my objective is to bring this point from here to bottom. What I can do is I can redistribute the weight. What do you mean by redistribute the weight? The top portion, I could bring it to the bottom. So I just cut the top portion and place it here so that the mass doesn't change. So what this configuration does, now the new object is red in color. What I have done is, I'm again telling, I have just removed the top part, and now my object is here. The mass is same. But now what happens is, the center of gravity will come more towards the bottom, more towards the base. So the idea behind is these two key points are very important. Or in order to maintain a stable design, you should widen the base, lower the center of gravity. That means you need to bring the weight to the bottom. Okay, so we have learned what center of gravity is. So here I have a small quiz-like thing. You won't be able to answer, unfortunately, because I have the control. So I will help it out. So find the center of gravity. I have two objects, objects A and object B, and my criteria is to find the center of gravity. This object is quite simple. Okay, it is a rectangle. It looks like a rectangle. This is also a rectangle, but the base of the rectangle is much wider. Okay, in order to find the center of gravity, what you do is draw two diagonals. This is not the actual way of finding the center of gravity. You need to hang it at different points and allow the gravity to pull it down, that line to be intersected, because the object is simple in shape, and for our consideration, let's make it simple. So here is our center of gravity point, right? So my center of gravity point is here, intersection. So here, without drawing lines, I'm just marking a point. It is just an approximation. You would be able to figure out the center of gravity by the geometry of the object. So what is here is the center of gravity is at much higher distance than the center of gravity of object B. So the center of gravity of object B is lower from the ground, whereas the center of gravity from object A is higher from the ground. So from this, you would be able to identify which is a more stable design. The stable design would be B. Why? Because two reasons, two conditions. In order to have a stable design, your base should be wide, lower the center of gravity, right? Compare the base of A and compare the base of B. The base of B is wider when compared to A. And the height of center of gravity of B is much smaller than A. So if you try to apply a force F on both objects and try to topple it, A will be easily toppled. B will also be toppled when the center of gravity line passes the base. For example, let me draw, this is B. So if I tilt it to a smaller distance, the center of gravity is here, and the center of gravity lies within the base. If I tilt to more, what happens? The center of gravity is gone above the base. This was the base, right? So this leads to an unbalanced condition. So again, these are the two key points in order to see an object and predict whether you have a stable design or an unstable design. What should be the criteria? You should have a wide base and lower down the center of gravity by some means. Okay, so now let's take it to a practical example. Here I have a car. It looks like a decent sedan car. Okay, so I have three examples of the car. Now let me consider the first examples, these three cars. What is car happening is the car is going on an inclined plane. Okay, the road is slightly tilted. So what happens? The car will also get tilted. So now let's check whether the car is safe to drive and how to choose a car. So consider that you're going with your parents to choose a new car. So what are the criteria? We always look at the color, the interior, the features, the specifications. But the most important thing is safety. We also look safety in case of whether the airbags are available, the seatbelt locking systems. But consider that we are driving at a slant or a slope. These things has to be considered. What kind of car you need to buy. Okay, so let's consider this condition. So this car, the center of gravity is located at the center approximately. So this base, the tire, right? Both the tire are the base. So center of gravity, let me change a color. Center of gravity is within the base. So the car will not topple. Topple is just go around this way. Okay, now the car is going in an inclined plane. The center of gravity always points straight towards the ground, earth center. Okay, still my center of gravity line is within the base of my tire. So this is also a good, this is also safe. When it is inclined more, what is happening? You can see, right? The inclination gets more and more. So when the inclination gets much more, what happens? Still, my base is here. These 2 points are my base points. So this center of gravity line is within the base. So still, this car is safe. This car is safe to drive. So let's consider a different car. So what has happened to this car is, this car is shorter. The height of the car is low. I can say, let me represent this as height, H1. And let me represent this car, which has a height H2. Now we could compare the height of H1 and H2, and obviously H2 is bigger, right? So consider a car like Innova, which is much taller. Nowadays, big cars are more preferred, and we tend to buy big cars, not understanding the risk of buying those kind of cars, right? So what happened from here to here? The center of gravity point was here at a height. Now the center of gravity point has moved up. Okay, from here to here, the center of gravity moved up. I told you, in order to have a stable design, your base should be broader and the center of gravity point should be much lower. So if you have that condition criteria, you would be able to have a stable design. So now there is an inclination here. There is also same inclination. These thetas are same. Inclination both angles are same. Here is also both angles are same. So here, but what happens? The car tend to topple. This I'm not considering what speed you are driving a car on that plane. It is just purely based upon the design and stability, whether the car would be stable or not. Why this topples? The center of gravity point is here, and the center of gravity line, when you extend it towards the earth center, what happens? It is away from the base. When this happens, it is going to topple. Okay, so let's consider about bigger vehicles. Let's consider a lorry. So lorry, generally the height of lorry is more, and what happens, because it has a more higher height, and people tend to load weight at the top portion. Okay, lorry bottom portion, you have the chassis, but the top portion, if the lorry is loaded, what is going to happen? The center of gravity is going to move up. If I load my lorry at the bottom, the center of gravity will come down. People tend to make this mistakes. Lorry driver, what they do is they tend, if they have a space to fill, let's see, this is a container of the lorry, space to be filled. If they keep lighter weight at the bottom and heavier weight at the top, what happens is the center of gravity moves up. So they could make a small change in loading their trucks. They could keep the heavier portion down and lighter portion up in order to bring the center of gravity to a much lower position, right? So now what is happening is, let's consider this lorry. So the center of gravity this is at the top. So for a smaller angle itself, what is happening? Almost the center of gravity line is touching the base. And when it is more tilted, the center of gravity point line is away from the base. It is not stable. So this lorry would topple for sure. So from this, you could find a pattern, right? So if you are going to buy a car, if you ask me which type of car is better, a car which has a center of gravity much lower to the ground. Consider race cars, Formula One cars. Do you know that people almost sit almost to the floor level? So they reduce the height of the car in order to, let me consider this Formula One car. I'm not good in design drawing. So the Formula One car center would be much more lower, so that it becomes much more difficult. So, and the width of the car would be also big, right? So let me consider these are the tires of Formula One car, and the driver would be sitting almost close, right? So you have a wider base. You have a wider base, and what happens? The center of gravity point is very low. So this car can be tilted to a very, very great angle, and still it will not topple because the center of gravity is within the base. Center of gravity line is within the base. So next time when you go to shop for cars with your parents, you do need to look for two factors. Check whether the width of the car is considerably a good distance, because nowadays we look for compact cars and we always tend to drive for city cars. We look for compact cars, but having a compact smaller width could be dangerous. You want to have a good wider width. More the width, more better it is, right? More the width, more better it is. And you want the car should be short. Some people think that if car is quite tall enough, we have good sufficient legroom. That is true, but if we consider toppling, that is not good. Okay, so next time when you go and tend to buy a car or make a decision, because it is a huge purchase and life comes into play when buying a car, and safety comes, and while driving also you need to really understand that what inclination you can drive the car. So some people think that my car can be tilted to a much better angle, and they drive it on a slope, and that would cause them to topple, right? So this is a comparison between two cars. This is a narrow car. This is a small car. Okay, this is a broader car. So these are being inclined to the same angle, theta. Okay, the inclination is same. Inclination is same. But what is the difference here? The center of gravity point is here, and the center of gravity line has gone out of the base. So it is not stable. So this tends to topple. The car will topple. Here, because of wider base, still we have some space, room here, right? It is not, the center of gravity line has not crossed the base. So this car is more stable, does not topple. And this is also another example. And look into the design factor, right? Why there should be designed like this? You know, this is designed in this way because more mass is concentrated at the bottom, less mass is concentrated at the top. So technically the center of gravity points comes at the bottom, and I told you wider base. So look, they could have completed with the cone, but why they have this rectangular or a square base is, you know, they wanted to increase the width. They could have a circular base, but they prefer this design in order to increase the width by a large margin. Okay, by a large margin, so that the center of gravity line is within the base, and the center of gravity point is also close to the ground. Okay, this is how far the center of gravity is. So this is close to the ground. So I think you would appreciate the design, why we have such a design like this, so that if accidentally someone tries to knock this phone with their hand accidentally, it won't topple. It will incline and come back to its original position because of its stability. Okay, so now having understood all those concepts, let's consider another case scenario. Now you are planning to have a fruit juice shop, okay, and you want to purchase some tumblers. By looking into the design, what kind of tumblers you would purchase? Okay, number one, you would purchase fancy tumblers. That is obvious for attracting customers, and you will try to buy tumblers which will accommodate less quantity of fruit juice, and it appears to be as if the quantity is more. That's another criteria. But if you consider the safety of the tumbler, because you will be making juices and often using these tumblers, there is accidentally you could topple it by applying a force, right? So this happens at our house also. We have a jug of water, accidentally some of our family members would knock it down by a margin, but it tends to topple. The jug tends to topple. So we need to consider what kind of glass to be bought. Okay, consider these two scenarios. In order to have a stable design, your base should be more, and the center of gravity should be low. Okay, base should be more and the center of gravity should be low. So consider this design. It has, let me change the color because it is blue. Let me make it yellow. Thank you. See, the glass is designed in such a way that what happens, if you consider half above and half below, more mass is at the bottom, right? The glass is more amount of material is at the bottom. So what it means is we would have a center of gravity at much lower point. This would be the center of gravity point. Okay, now look in this tumbler. Let's divide this into half also. So here the mass, here we have less material, here we have more material. So you could expect the center of gravity to be above, okay, not at the center. By looking the image itself, you would be able to find out how the center of gravity is, right? So here the center of gravity point is here. Here the center of gravity point is at the lower position. Now let's see here. Again, draw a line just bisecting the glasses. So here it is just at the center of gravity point is center. That's number one, right? Number two, let's consider the base. This is the width of the base. This is my base, right? Here, how is it designed? The base is much narrower when compared to the first glass, right? The base is first narrower. Let me have this as first glass condition, second glass design, third glass design. Okay, in the second glass design, I have a narrow base. For a third glass design, I have a broad base. So now you can compare all the three glasses. I told you for a stable design, you should have a bigger base and lower center of gravity. Let's compare 1 and 2. It's been messy. Now I'm going to erase it a little bit. So yeah. So let's compare 1 and 2 here. Which has a bigger base? 1 or 2? Obviously 2 has a bigger base. Which has a lower center of gravity? 1 or 2? Obviously 1. Which whose center of gravity is at much lower distance from the ground. Okay, so comparing these two glasses, glass 2 might look fancier, but you might have this kind of glass in a shop. But if you're buying it for a house, you would definitely buy glass 1, because accidentally, if you apply a force, accidentally, let me erase a lot of things going on. Accidentally, if you tend to apply force, what happens? Force. Accidentally, I apply a force. Glass 1 tend to be more stable. It won't topple and it won't break. Whereas glass 2 will break for sure. How about glass 3? When comparing glass 2 and glass 3 has a much wider base and the center is at the center. Okay, so glass 3 is also a better design when compared to glass 2, but unfortunately in most of the juice shops they prefer glass 2, so which is prone for breaking, but it is good for aesthetic point of view because it consumes less amount of juice and it looks good and nice longer. But if you decide to buy it for your house, I'll go with glass 1, or you can go with the tumbler 3, glass 3, which is a much better design. I would never prefer this design because this is prone to breakage due to tumbling. Okay, now with that same idea, this has been built. Okay, so if this kind of an arrangement doesn't fall, what does that mean? What does that mean? The whole system will have a center of gravity, right? So that center of gravity should be at some point. I do not know because now the shape is more complex. The shape is not straight. But if someone says that these books does not fall on this arrangement, what does that mean is the center of gravity line should be within the base. Now consider, where is my base support? Okay, so from here to here, I can't, there is no support after the edge of the table, so the base support is here and here. And if this condition is stable, what should the center of gravity line be passing through? It should be passing through this line, passing through the base. It can pass through this, it can pass through the base, anywhere. But our common sense says that because the weight is here, the center of gravity, the center of mass should be somewhere here. And I'm not bothered because this is a stable design. So you can also trick your friends by making this setup. How do you make this setup is, I told, to be stable, the center of mass should be at lower position and the base should be wide. So in order to make this kind of arrangement, I would use, what color? I'll change my color. I would use a bigger, longer book at the bottom and a heavier book at the bottom. Okay, the next book should be heavier, but there should be a little bit of offset from the first book. Okay, it's hanging little bit, and the next book which you keep about, which should be lighter, little bit offset. So what I'm trying to do is, I'm trying to make my center of gravity point lie within the base. That is the concept. If you are able to achieve, you would be able to get this design of arch. Okay, get the design of arch. So next time when you see an arch in building design or anywhere, always think about why it is stable, what could be the conditions to make it stable, and how could you improve the design, right? So if I make this book much more wider and heavier, it will be much stable. That means I could have a book, one more book at the top. Okay, so you could try it. You have free, when you are free, you could try this kind of experiment. And here I want you to predict whether this athlete will fall or not. Okay, there is a center of gravity point given to the athlete. Due to his physical structure, his center of gravity comes to that point. So let me draw a line straight pointing towards the ground. So let's see how his base is. Let me choose a different color for the base. So his base, his 2 feet are wide, right? So this point and this point, he has kept his base wider and he has leaned forward in order to accelerate fast, right? In order to start to run faster, you need to have a great acceleration, right? So in order to accelerating, he's pushing him forward to get that acceleration. While pushing him forward, what happens to the center of gravity? The center of gravity also moves forward. So in order to balance, he has to keep his leg here. If his leg would have been at this position, consider this orange line to be as his leg, what will happen? The center of gravity is out of the base. Okay, now I think you understand. If his leg was here, he would definitely fall. He would definitely fall. So these are some of the things that athletes need to consider while training. They can concentrate on their strength, but on the same way, what is happening? They need to concentrate on mechanics too. Okay, they need to concentrate on the mechanics too. So that's the reason why athletes, when they run, they start from a low to top position. They always wanted to be at the lower position, because when they are at the lower position, the whole center of mass is always concentrated at a lower distance from the ground. See, when he is standing up, the center of gravity point moves up, 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 up. So when you are accelerating, your center of gravity to be at the bottom, right? So next, let's consider. I'll just go a little faster. I think I'm slower, have lots to show. So I want you to predict. This lady is standing on her feet. She's doing a yoga. She is stable. So if she is stable, where will the center of gravity line be passing? Her base is this. She's standing on one leg. So without doing any calculation, doing any engineering, you should be able to predict that a center of gravity should be here. Because if the center of gravity line moves out of the base, she has removed one of the leg, right? So because she is stable, the center of gravity should always pass through her base. Okay. Now let's see a sumo wrestler. So sumo wrestlers, you can see always they are at the crouched position and they keep their feet apart. Okay. And the center of gravity, let this be the floor. And the center of gravity point is here. And this is the distance or height of the center of gravity from floor. If this person would have been standing, sorry for my bad drawing, I guess you understand what I'm trying to say. If he was standing, the center of gravity point would be at a much higher position, right? So I told you, in order to be stable, the center of gravity have to be lower, the base should be wider. That is why sumo wrestlers keep their feet wide and crouch down. So now, if we consider about force also, if we tend to apply a force in this direction, the red arrow, he is much stable because he need to be tilted by a large angle. You have to apply a huge force in order to topple him. But if his legs was much narrow, if his feet was somewhere here in this green box, it is easy to topple, right? You get this idea. So you can figure it out what makes a design much more stable. Next year, there are two sumo wrestlers trying to compete. The whole point of sumo wrestlers is to topple another person. We have this wrestler, let me name this wrestler 1 and this wrestler 2. By looking this picture, looking the screenshot, now you should be able to predict which wrestler will fall down. Okay, so let me help you out in order to find it by looking at it itself. Let's see. Both the wrestlers' feet, one feet is up. So this wrestler's base is here. So this wrestler's base is here. And you see this, the wrestler 2 has not bent so much. Whereas wrestler 1 has bent a lot. Okay, so his center of gravity has moved somewhere here. This person has not bent. This center of gravity would be here. This would be at a lower position because he is crouching. The person 1 is crouching. So his center of gravity would be lower. The person 2 is standing. His center of gravity would be at a higher point. So I told you, for a stable design, lower the center of gravity is good. If you consider that, this person is good. This person is not that good. But the wrestler 2, he has not bent that much and his feet is well stable. So if I draw a line, it is well within his base, right? This is his feet base. Whereas his feet is here. but the center of gravity point is away. So the center of gravity point is away and the feet is somewhere else. So this is not a stable, because I told you that the center of gravity line should be well within the base. So from this, you can make a decision who would fall. The person 1 would definitely fall. The person 2 is stable. So by looking at it, you could predict. Okay. Now this is the third scenario. So what is happening? Look at this wrestler. Wider base. And he's crouching. So his center of gravity is somewhere here. Let's draw a center of gravity line which points toward the Earth center. So this center of gravity line is much within the base. Whereas what has happened, look, I'm drawing a stick diagram. He is bent, right? He is bent and his feet is here. So what is going to happen is his center of gravity, his center of mass would be somewhere here. If I draw a line, it is away from his feet. So the sumo wrestler, who is very stable, would be easily able to topple the other wrestler. Okay, this is not only in sumo wrestling. This happens in almost all kind of sports. Even in cricket, now there is an IPL season going on. You could see catches being taken, and you can see some of the catches which is terrifically taken. They are able to take those catches if they are very stable. They fall even though when they make a dive or attempt to catch in a diving position, they needed to be stable. And you can also find some silly catches which are directly to their hands would be dropped because they would have kept their feet in the wrong position. The body, they would have bent in one side, which would cause them to topple. Okay, so as of now, we have learned what makes a design stable. What are the criteria to make a design stable? 2 criteria: wider base, lower center of mass. Okay, and the center of gravity line should always pass between the base. This is that concept. Now let's move to a different concept. Now let's, as we are in mechanical series, so let's discuss the difference between force, weight, and let me erase a little bit. Okay, let's find what's the difference. Let me change my pen. I have an issue. Okay, so let me, I'm in my pen mode. I'll just check eraser, pen. Okay, difference between force, weight, and tension. You need to know what are the difference between these 3 terms: force, weight, tension. Okay, the peculiar thing is you would have learned in your 12th about force, you would learn about weight, and you would have learned about tension. But the important thing is what you understand with these things. Are they different? Are they same? The important thing to know is, are they same or different? Okay, so let me give you an example. Okay, my name is Naseem. My family members, close friend call me Naseem. Okay, my colleagues call me sir. Okay, my wife call me Bubbly. It's all different names. Okay, my wife call me Bubbly, and my colleagues call me sir. My close friends and family relatives call me Naseem. I'm asking you, Naseem, sir, and Bubbly, do they represent different person or do they represent me? This is me. Okay, I'm happy. I'm not yellow in color. I'm happy. Okay, these all 3 names is the same, right? You could call this in different way. Samely, let me erase. Same way, these three terms are same. Okay, what are the three terms? Let me change the color. These three terms, force, okay, force, weight, and tension. These three terms might have different names, but they mean the same. Because you know that unit of all the three terms you would have studied in 12th is newtons. All the three are same. So what is the basic difference between these three names? Okay, a push or a pull is called as a force. Here I have written, right? So let me erase. So shabby. So a push or a pull is called as a force. Weight is also a force that is caused due to gravity. Okay, so let me consider a box. If I am pushing, I will call it as a force. I am pushing or pulling. Push or pull. Okay, I am pushing or pulling. This is called as a force. This is a force. So next, let me consider. So this object is always attracted, pulled by whom? There is an imaginary person who's pulling this object straight towards the ground. Who is that person? That person is gravity. So force due to gravity is called as weight. Okay, push or a pull is called as a force. And if that force occurs due to gravity, who's pulling? This is me. This is me who's pushing and pulling. If the gravity pulls, it is called as what? It is called as weight. And what is tension? Tension is also the same thing. You have a pole, you attach a string to that pole, and if you're tending to pull it with a force, what happens? There is a tension created in the string or the rope. So the force in the rope is called as a tension, right? So now we understand force, weight, and tension. All three are same. And force, we name it when an external body is being pushed or pulled. Weight is a force due to gravity, and tension is a force in strings. You need to understand that. Okay, now let's practically use this concept in order to lift the weight. Okay, so I just want to explain you very short and simple. So here my objective is to lift a weight. I have a weight, mass W. If I'm lifting it, I have to bend. This is my head. With my hands, I have to lift it, right? So much of stress goes on my spine. I might injure myself. So what I'm doing is I have to pull it up. But with a pulley system, I have a pulley and I have a string attached over the pulley. One end, weight is connected. Here, I can pull it easily. Okay, so here I have to pull it up. Will put so much stress on my back. Here I can use my weight in order to pull it down. I have to pull it up. Here I have to pull it down. Here I could use my weight to pull it down so it does not hurt my back. By just using a pulley, my work has been simplified. So here is a pulley system. More than one pulley, you call it as a system, right? So why you use a pulley system? You use a pulley system in order to lift it much easier. So whatever the weight here, let me change the color. Whatever the weight here, I have to put the same amount of effort on the other hand if I use a single pulley. But the advantage of this single pulley is I'm changing the direction of force. But here I have a pulley system. Okay, there is the same amount of force because this is a single rope. Same amount of force is always present in this rope. So if I cut this rope here, there is a tension. I told you there is always a tension. Force in strings is called as tension. So it is as if two person is pulling. Okay, so the same tension is here. Same tension is at the other end also. I'm pulling at this end. last end I'm pulling. If I cut it, you can see that this has to be pulled. In order for this to be lifted, the same amount of weight should be balanced. So there is a T tension here, there is a T tension here, little bit of mathematics in order to be balanced. How can I write an equation? Tension plus tension will be equal to my weight, which I'm pulling. So I have 2 times the tension is equal to my weight. So what is my tension in my string? It is weight by 2. Let's do the math. If I need to pull a weight of 100 kg, what force should I apply here? My force here, which I have applied, is just a tension. How much is the tension here? If W was 100, W by 2 would be 50. So now there is an advantage. In order to lift a weight of 100 kg, it is enough for me to apply a force of pulling 50 kgs. So this makes an advantage. Here, let's see what is happening. You may weigh 200 kgs. Will the person be able to lift a 200 kg load? No, right? With the help of pulley, this could be achieved. So I'm making a construction. So what happens? Each string has a tension. Tension is developed here. Tension is developed here. Tension is developed here. Tension is developed here. The same tension, I need to pull it. So how many tensions? 1, 2, 3, 4. So 4 times 4T will be equal to, in order to pull it up, this has to be balanced. 4 tension upward and the weight is always downwards. It's pulling in the other direction. Okay, so 4T is equal to 200. So what will my T be? 200 divided by 4. See, isn't it amazing? So 50 kgs, in order to lift a weight of 200 kg block, I need to apply a force of 50 kg, which is much easier. Now look, how does this string system becomes? Okay, so here, the weight is here. So I have to apply a tension. So how many strings attached? 1, 2, this is 3, this is 4, and this is 5. So here my equation becomes much more simpler. 5 times tension should be equal to 100 kgs. So what is my tension here? It will be about 20 kgs. So it is enough for me to put a force of 20 kgs and pull it. So here I am having a great advantage, right? So look these systems. For this I need to apply 100 kgs. Here I need to apply 50 kgs force to pull this one. Here 3 times tension is equal to 3T. Let me write this equation. 3T is equal to 100. 3T is equal to 100. Here 1, 2, 3, 4, 4T is equal to 100. Here 5T is equal to 100. The more the complex the system becomes, it is easier. Okay, so next time when you go to the gym, I know that most of them would trying to go to gym during their free time, and I want you to look into the gym and you have the lot of pulley systems and how those systems are arranged. Are you actually lifting the weight which you put on the weights in the cable rope, or actually you are reducing less weight? Here the person is lifting actual weight. So whatever the person is applying weight here, he has to pull it. So if you have more pulleys, you could reduce the effort he is applying, right? So next time when you go to the gym or apply, I want you to look in this way. Okay, I have more to cover, but unfortunately I won't be able to finish it on time. So I would like to wind up my session. And before winding up, I would again like to thank the management. I would like to thank the management for giving me this opportunity, and the department also. Thank you, SA Engineering College, for having me here. Thank you.
Thank you so much, sir. The session was very informative. It was very nice, sir.
Thank you.
Thank you, sir. Now it's time for quiz. So, dear participants, kindly open your browser and type the URL as www.kahoot.it. This is shown on your chat box. www.kahoot.it. Type your URL as www.kahoot.it, and participants kindly participate yourself with your original name. So winners will receive appreciation certificate. So after result announcements, winners kindly type your name and mail ID on chat box immediately for getting the appreciation certificates. Thank you. Now the section will hand over to Sharmi.
Good evening to everyone. This is Shami. Let me start our quiz session. Everyone, open your browser and type www.kahoot.it. I repeat, everyone, open your browser and type www.kahoot.it, and you will be redirected to a page to enter your game pin. And your game pin is 9129900. I repeat your game pin 9129900, and enter your nickname. Okay. Only 5 participants are joined. Let me wait for some others to join. Now again I repeat the instructions. Open your browser and type www.kahoot.it and enter your game pin as 9129900. Okay. Level members are joined. Okay. Guys, join in the Kahoot session.
Participants kindly join immediately.
Level members are joined. I repeat the instruction. Open your browser and type www.kahoot.it and enter your game pin as 9129900. Okay. 12 members are joined here. Let me start our session. And your first question is, which law of motion states that nothing moves unless a force acts on it? Your options are third law, second law, first law. This is not of the law of motion. I repeat the question. Which law of motion states that nothing moves unless a force acts on it? 6 members are answered. 8, and time up. Okay. 3 members are answered correctly. Now Balaji is in the first position with a score of 857. Let me move to the next one. And your question 2 is, which law of motion states that a force will push or pull an object in the same direction as the force? Your options are fourth law, second law, first law, and third law. I repeat the question. Which law of motion states that a force will push or pull an object in the same direction as the force? Time is running out. 8 members are answered. Okay. 4 members are answered correctly. And again, Balaji is in the first position with a score of 857. Let me move to the next one. And your third question is, what is barometer? A machine that measures as air pressure, a type of hot air pressure, a tool that measures as temperature, a power of nobleman. 30 seconds is left. 8 members are answered. 9. I repeat the question. What is barometer? And 11 members are answered. Okay. 7 members are answered correctly. Now again, Balaji is in the first position with a score of 1758. We move to the next one. What force pulls object towards the head? Your options are acceleration, pressure, gravity, and friction. This is the basic question, guys. And time is running out. Only 12 seconds are left. 9 members are answered. 6. Okay. 9 members are answered correctly. Let me move to the scoreboard. Again, Balaji is in the first position with a score of 2587. We move to the next one. Which scientist first figure out how gravity works? Albert Einstein, Archimedes, Isaac Newton, and Carol Linnaeus. I repeat the question. Which scientist first figure out how gravity works? 10 members are answered and time is running out. Okay. 8 members are answered correctly. Again, Balaji is in the first position with a score of 3403. Okay. Which object in our solar system has the most gravity? The planet Jupiter, the sun, the earth, and the moon. I repeat the question. Which object in our solar system has the most gravity? The options are the planet Jupiter, the sun, the earth, and the moon. Only 6 seconds are left. Okay. 3 members are answered correctly. Again, Balaji is in the first position with a score of 4231. Good work, Balaji. Which law of motion states that when a force acts in one direction, it creates an equal force in opposite direction? Your options are fourth law, second law, first law, and third law. This is very basic question, guys. Okay. 9 members are answered correctly. And again, Balaji is in the first position with a score of 4231. We move to the next one. What is a motion? And your options are changing size, moving from one place to another, changing shape, all of the above. I repeat the option: changing size, moving from one plane to another, changing shape, all of the above. 10 members are answered and your timing's lifting out. Okay. 8 members are answered correctly. We move to the scoreboard. And again, Balaji is in the first position with a score of 5,105. We move to the next one. What is acceleration? And your options are changing shape, moving from one plane to another, increasing speed, and slowing down. 4 members are answered and your time is running out. Only 30 seconds are left. Come on, guys. Only 7 seconds and 9 members are answered. 1, 0. Okay. 9 members are answered correctly. We move to the scoreboard. Now kicker is in the first position with a score of 5,360. We move to the last question of our quiz. Okay. Where ID pressure highest? In an aeroplane, at the bottom of the sea, high in the atmosphere, in a house. I repeat the question. Where ID pressure highest? The options are in an airplane, at the bottom of the sea, high in the atmosphere, in a house. 7 members are answered and you have only 2 seconds. Okay. 8 members are answered correctly. Now we move to the podium. And the third position goes to the kicker. And the second position goes to the Vidya. And the first position goes to the Arini with a score of 6,268.
Winners, kindly give your full name and mail ID on chat box immediately. Congratulations, winners. Kindly type your full name and mail ID on your chat box for appreciation certificate. Kicker, Harini and Vidya. Kindly type your full name and mail ID on chat box immediately for your appreciation e-certificate. Thank you, Vidya Sarathi.
The participants are requested to kindly fill the feedback form which is being provided in the chat box. They'll be provided with an e-certificate for participation. I'm grateful to the esteemed delegates of the webinar for their presence and efforts in making this event a great success. I also extend my sincere thanks to our principal, to our honored resource person, and the heads of the departments of Civil, Mechanical, CSBS, Cybersecurity, CSE, IT, ECE, EEE, AIDS, AIML, and also Humanities and Science. Once again, I thank everybody for making this event a great success.